Here is the solution for these questions. Question 15. The vector A is twice as long as vector B. So we can say vector A equals to 2 times vector B. The angle between the vectors is 25. So let's say theta equals to 25 degrees. And the magnitude of their cross products is 16. That means magnitude of A cross B equals to 16. Determine the magnitude of B. So that is the question here. Now you know what is A cross B. Now A cross B is equal to magnitude of A times magnitude of B times sine of angle between them. Correct. So that is what A cross B is. Now we are given magnitude of A cross B. So let's say magnitude of A cross B is the magnitude of all this, right? Now I purposely put magnitude here. Sometimes the angle could be such that you get negative answers, right? Sometimes, it's rare. Now here, A cross B. Now A is twice B. So we can use this value of A as twice B. And we know what A cross B magnitude is, which is 16. So we'll use this equation and write 16 here for A cross B. And in this case, A is twice AB. So I'll write 2 times magnitude of B. Is it okay? And then we have magnitude of B and sine of angle, which is 25 degrees given to us. So that is what is given to us. Okay. Now, what is B? That is to be found. So we can rearrange this and find our answer. So let's rearrange and find our answer. So that means B square. So we can simplify this as magnitude of B square, that is B times B, equals to 16 divided by 2. And also sine of 25 will go in denominator. Correct? So that is what it is. So we can use calculator to find this answer. Now, which is B equals to square root of, so 16 divided by 2 is 8, so get 8 divided by sine of 25 degrees, correct? Square root. And if you use your calculator to get this answer, then it should be 4.57. So I'm not using calculator, just writing down. So you check if it is same or not, okay? Thank you. Let's move on to the next question, which is question 16, which says, calculate the amount of work done when a sledge is pulled 50 meters by a force of 30 newtons, right? So we are given displacement. Let's say displacement is 50 meters, force is 30 newtons, right? Applied at an angle of theta 30 degrees, right? And calculate the amount of work done. So work done is a scalar quantity, right? So work done, I should not write vector here. Work done is scalar quantity, which is force dot distance, displacement rather, okay? So that is what it is. And you know, work done will be equals to, force is 30 newtons, the magnitude of force. F dot D is, let me first write magnitude of force times magnitude of displacement times cosine of angle between them, cosine of 30 degrees, right? So that is the dot product. So now it is, force is 30, so we'll write 30 newtons. Okay, 30 newtons, I should put them in brackets, times 50 meters, which is displacement, okay, times cosine of angle 30 degrees, correct? And if you do this calculation, you should get 1299 joules. Right? So I've written answers more for my convenience. So I don't have to really use calculator. So we just figure it out like this. So it's 1500 and less than 1500, so it makes sense. It's approximately correct, right? So that is how we have to do these application problems. So they are straight applications for cross and dot product. I hope you understand and appreciate it, right? Thank you.